Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over what scientific notation is and how to write it. So let's get into this. So what is scientific notation? So scientific notation is just a format in which you are going to write numbers. So there's standard notation and then there's scientific notation. So standard notation is the normal way we write numbers, right? So if I asked you to write, 320,000, you would write 320, comma, and then 30. So this would be your standard notation. This is standard way of writing numbers that you grew up with your whole life. So 320,000, or if I asked you to write 226.5, you would write 226.5. So both of these numbers are in standard notation. Well, what is scientific notation? Scientific notation is a very is a format in which it allows you to conveniently write really large numbers or really small numbers, right? So if you, for example, if you write a large number, let's say 320 zero 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 zero. And so let's say that number is scientific notation. I don't know what the name of this number is or how to say it, but you can see how inconvenient it would be to continue to write this number over and over and over again in a paper or whatever, right? So there's got to be an easier format to write that number, and that's where scientific notation comes in, right? So you could do this also with small numbers too. Instead of this long number, you could have 0.00000000000000000320, right? So that's a really small number. Decimal points right there. So again, very inconvenient to write these numbers. There's got to be an easier way. So scientific notation. Well, what is scientific notation? Well, simply put, scientific notation is the format where you're going to have to move the decimal point one way or another. So if the decimal point is over here, you're going to move the decimal point to make this number so that it's a number between 1 and 10. So what's going to happen is you're going to end up with some number, we'll call that uh, capital N. So you got some number N, and that some number is going to be a decimal point of some sort, or maybe not, right? So you're going to have usually some number between 1 and 10, right? So this number is going to be between 1 and 10. So it's not going to be equal to 10, but it could be equal to 1. So it could be equal to or larger than that number. So let me write this in a different way. So n, whatever n is going to be either smaller, it's going to be smaller than 10, but it's going to be greater than or equal to 1. So this n number is between this. So then you're going to multiply that by some factor of 10. So it's going to be multiplied by 10 raised to some power, right? And n could be 1 through whatever. And it can be negative too, right? So it could be -1, it could be -3, it could be a +5. So this is the format of scientific notation. So let's take these two numbers as an example. How would I write these in scientific notation? Well, the rule that I want you to think of, that rather than thinking about, oh, do I move the decimal point to the left? Do I move it to the right? Just think about bigger or smaller, right? Is it a large number or is it a small number? So large numbers, I'm thinking something 10 or greater, right? Something larger than 1, but usually 10 or greater is what we're going to think about as large numbers. But they're definitely going to be, usually a large numbers, right? Like this, right? Or really small numbers, numbers less than 1, usually. So if it's a number less than 1, that's what we're thinking, small numbers. numbers 10 or greater, that's what we're thinking large numbers. Okay, so when you're thinking large numbers, that's positive exponent for your scientific notation. So positive, large numbers, negative, small numbers. So if you can remember that relationship and remember that those two go together, so large numbers go together with positive exponents, negative exponents go with smaller numbers, right? Small numbers, negative exponents, large numbers, positive exponents. Okay, so here we have a large number. So how would we write this in scientific notation? Well, we got to move the decimal point until we get a number between 1 and 10, right? So obviously this is definitely not a number between 1 and 10. So I got to move the decimal point, and I got to count the number of ways number of times I'm moving the decimal point. So if I move it, we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. If I stop here, that'd be 19 times, but then my number is 32, right? 32 is not between 1 and 10. So I got to keep going. So 19, 20. So now the decimal point is here. Now I have 3.2. 3.2 is between 1 and 10. So 3.2 is my number. So n is 3.2. So I write 3.2, right? And now I'm going to do my times 10 after that. Times 10. And then the exponent is the number of times I moved my decimal point. So I moved it 20 times. It's a large number, so it's got to be positive. So remember, positive, large number, positive, right? So since I started with a large number, I moved it 20 times. Therefore, it's positive. So 20, it's going to be a positive 20. So then this would be the scientific notation for this long number. So now you could see that this is quite convenient compared to this. So you could write this a number of times over, right? Rather than this. This takes a lot less space. Okay. So that's the scientific notation. This is the standard notation. Okay. So what about this number here? Right? We could do the same thing. I'm going to move the decimal point over until I have a number between 1 and 10. So right now it's a really small number. So I'm going to move the decimal point over. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If I stop here, notice it's 0.320. 0.320 is less than 1. It's not within the range. So it's outside the range. So I got to move it again. I forgot how many times I moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I got to move it another one. So 19. Now, again, I'm between 3 and 2. So I got 3.20 here. So 3.20 is my number because now that's between 1 and 10. If I go another one, that would be 20. That would be now 32. I went too far. That's that's larger than 10. I don't want that. So 19. So 19 times. So I moved it over 19 times to get to 3.2. So here would be 3.20. And then I multiply it by 10. I have the times 10. And then now my n here, my exponent. Well, the exponent here, I moved it 19 times, but it's a small number. So that means it's going to be negative. So it's a negative 19. So this would be the scientific notation way of writing this very, very, very small number. So that's how you would do that. And you could go backwards too. You can go from scientific notation to standard, right? So let's do, I want to do a simpler numbers. So let's say I had 3.3 times 10 to the third, right? So 3 times 3 times 10 to the third. The 3 here is positive. So remember, positive means big number. Big number means something greater than 10, 10 or greater, right? So the exponent tells you the number of times I need to move my decimal point. And which way I'm going to move my decimal point? I'm going to move it in the direction that makes the number bigger. Well, if I move it in this direction, I've just made it 0.33. That's smaller. That's not in the right direction. So I'm going to move it in the direction that makes it bigger, which is this way. So that means I'm going to move 3.3, move the decimal point 3 times in this direction to make it bigger. So 1, 2, 3, put zeros there. And now I have my decimal there. So this is 3,300. That would be the standard notation for this number in scientific notation. I could do it for a small number too. So if I had 3.3 times 10 to the negative 5, negative means small number. That means less than 10 or less than 1, right? So that means I'm going to move the decimal point 5 times because I have the exponent 5 there. And I'm going to move it in the direction that makes the number smaller. So here I have 3.3. If I move it this direction here to the right, I've increased it to 33. That's making it bigger. I don't want to make it bigger. I want to make it smaller. So I'm going to move it in this direction. So I'm going to move it 5 times. So 1, 2, 3, 4, 5. So I'm going to put zeros here. And so now I have 0.0. I have 1, 2, 3, 4 zeros. 1, 2, 3, 4. And then 3, 3. So this would be the standard notation for this number here. So you can go back and forth in the scientific notation, from scientific notation to standard, or standard to scientific notation. I hope this was helpful. I hope you enjoyed the video. I hope you learned something. If you like this video, hit the like button, subscribe to my channel, hit that notification bell so you can be notified for any other videos I put out. Put comments in the comment section. Let me know what you think. Do you have any other questions? Thanks for joining me. Have a great day.